Recording. Okay, hi Sebastian. So my name is Patrick. I'm based in Geneva, Switzerland. I'm passionate about AI ML since quite a long time. My background is technical, but I'm currently managing projects and programs for AWS. David?
Yeah, my name is David Sarwine. I'm a senior data scientist in AWS. I've also worked with Patrick, where I basically help build some of the largest customers, their AI solutions on AWS.
Yeah, thank you for the kind invitation. And, you mentioned AWS. It must be a busy time because, probably most of the AI world is running on AWS now. But yeah, and also thanks for inviting me and thanks for, the patience. We had issues with the Zoom link. Finally, got it resolved. Happy to be here and happy to chat about, any questions you might have. Or in general, just happy to chat about AI.
Sure. This meeting, by the way, is purely private, not related to AWS, but it happens that we are working for AWS. Yes. Anyway, I just wanted to ask you how you manage to catch up with all the news and, there's so much happening every day and you can spend your time on reading books, articles, posts and everything. How do you have a trick or something?
Yeah. I wish I had, like you said, it can be, if you're not careful, it's a full-time job, basically, to keep up with everything. There's so much stuff coming out every day. For me, I mean, there's no trick. It's really, it takes some time, but I think also just going offline sometime. I like reading offline. So it's weird, but I send articles that I find interesting to a e-reader. That is, the e-reader is online to download the articles, but then I just read them offline, like papers. And also I just export a blog posts as PDF and I just sit down every day. Usually 1 or 2 hours in the morning, and I just read. And yeah, that's I think the only way. Otherwise, for me, it's like if I'm doing that on the computer, I get distracted. There's too much, and then you get stressed because there's so much happening. So I say also I don't follow everything. I'm quite focused on large language models these days. And even in the large language model space, I don't read everything. It's like specific topics. Right now, I work, for example, on reasoning models. So I only read about reasoning models at the moment. Because yeah, I was a moderator at Archive a few years ago, and as moderators, I was in the machine learning category, basically checking machine learning papers. And back then, there were like 100 to 200 papers each day coming out, and you can't read them. You can just only skim the titles. And nowadays, I think it's 200 to 300 papers that come out every day. It's like, yeah, you have to prioritize basically. It's you have to basically accept that you can't read everything.
And David, you have a question? Please.
I mean, I love lots of questions, but I think just one follow-up on this is that I think it's quite impressive that you read them offline, because very often I read a paper and I need like a lot of other references to just check.
I usually take notes and then check on them later, because yeah, otherwise it's for me, I would never finish. Otherwise, I
too
get
distracting.
distracted. Yeah.
Yeah. Okay.
Okay. But okay, let's start with maybe two general question, but I start. How do you see the future of LLMs, right? What's the future? Do we continue to build larger and larger LLMs or smaller, or what are we gonna? Are they gonna be more specific, or how? What's the?
Yeah, it's interesting. I honestly, it's just speculation here, what I'm saying, because no one knows for sure. But I think there are two trends. So one is towards both, basically. One is towards smaller LLMs, and one is towards bigger LLMs. So with smaller LLMs, I think that's what I mean here is like specifically on-device applications. For example, yeah, Apple, popular example. I would say they are not the best LLMs, but they are LLMs that fit on a phone. So running them offline for privacy considerations, but also, yeah, to have like offline faster access. It's free if it can run on the device in the sense of you don't have to connect to any service. For me, for example, when I live in the US, the internet coverage is still spotty with the cell phone. Sometimes I'm driving And I'm only using Siri when I'm driving. I press the thing on my steering wheel and say, hey, navigate home or navigate to XYZ. And most of the time it doesn't work because it needs internet. And so I can see the small LLMs are useful if you maybe want offline or fast generation tasks, but they're not the most powerful ones. I think the trend is still towards making better LLMs, bigger and better LLMs. Now with GPT 4.5 that came out like last week, we have seen that bigger is not necessarily better in that case of scaling LLMs. I think there's a caveat though, because it's still the first iteration of GPT 4.5. So people are comparing it to O1 and so forth, but O1 works really differently. Like O1, no one knows for sure, but I think it's a smaller GPT-4o model or GPT 3.5 model that has been undergone reinforcement learning training for reasoning, but then also heavy inference time compute scaling. So making the LLM better by putting more inference compute to it. And I think, I mean, no one knows for sure unless you are an employee at OpenAI, but I think the GPT 4.5 model, it is not doing any of that yet. But if you add that on top of it, it will be better, right? I mean, so you can, so there's like the interesting trade-off whether you want to make the LLM bigger in terms of spending more training compute, more data, more parameters. It's a front investment, so you spend money on that, or you spend money later. You make or keep the LLM small, and then you throw in more inference compute, and then you make the LLM better at inference time. And I think it depends on who your customers are, how many customers you have. So, for example, if you only have a few queries each day, it doesn't make sense to spend millions of dollars to make a bigger LLM. But if you have millions of customers each day, you can save money by not doing too much inference scaling. And so inference scaling, what I mean is it is basically there are different techniques. The simpler one would be chain of thought, where you can say explain your answer step by step, and then it generates a longer output. And yeah, roughly you can say if the output is twice as long, it will be twice as expensive because you have twice as many tokens, and it's an iterative process. And the other one, it depends. We don't really know what OpenAI does. And interestingly, DeepSeek, they said in the paper, they didn't do any of that yet. So they could technically put that on top of their LLM and get even better LLMs. So the other techniques are usually using a verifier model. So you have the simplest way would be to have the LLM generate multiple responses. So you can have, when you change the temperature, you have the LLM generate, let's say, 10 responses or 10 responses. It will be 10 times expensive because you have 10 times as many responses. But then you can select the correct one or the best one. And with that, you can do either majority voting or you can have an external model. And verifying is simpler than generating. So you can have a smaller LLM that just compares or double checks the answers, but it will be more expensive, but you can get better results. And there are multiple methods that have more sophisticated sampling, like beam search, backtracking, self-verification, and so forth. So yeah, but it's all expensive during inference time. So it's interesting when people were comparing O1 to DeepSeek. DeepSeek, I mean, I don't know about the app itself because they didn't talk about it, but in the paper, they mentioned specifically that they were not doing any inference time scaling. So I think it's almost like an apple to oranges comparison. It would be interesting to see what happens when you do inference time scaling on DeepSeek R1, for example. But yeah, long story short, your question was essentially where's the trend going? I think short term, we will see more. I think we will see for very short term more inference time scaling. And then I think there will be the time. Right now, people just focus on getting the best LLM out there. Like companies, I mean, Google is a bit interesting. Google, they focus on the Gemini Flash models, the cheaper ones, because I think they really want to make that already not as expensive. But other companies, they focus really on let's get the best LLM out there for the benchmarks and PR. But then I think there will probably be a trend where it goes back a bit towards making that sustainable. I mean, I don't know for sure, but I can imagine most of the LLM companies, all the LLMs are VC subsidized, where they make a loss running them. I mean, not all of them, but I think it's not it's right now the phase where people just want to make better LLMs and get people
Spending
adopted.
money.
Get customers or get people used to them, and then at some point, I guess either the LLMs will get worse to make them cheaper, or they will get more expensive. And the interesting thing is what on alternative architectures, but yeah, I can talk more about that, but I think right now everyone is still based on the transformer architecture because it just works so well. And yeah, no one has really trained a big state space model yet. So it will be maybe interesting to see if that's even something we will see in the future.
In fact, you started covering a few of our next questions, but David,
okay.
I think you started. You had a question about benchmark and
I think that is like because that's something I'm quite interested in. Because you several times you mentioned people are trying to build better and better models, and there's a lot of focus on famous benchmarks like MMLU and so on. And I really I think on the one hand people start to get lost what this actually means, and we also don't always see these big leaps that we saw before, right? So I think we're really starting to see that people are gaming these benchmarks more and more. And I see always benchmarks as like one way to really, you set good benchmarks and completely new benchmarks, and then you work towards them. And this is something that I'm missing a little bit at the moment. And I'm wondering what your opinion on this is, whether the current benchmarks will get us to the next leap in performance, or we should take a new approach.
Yeah, I think the benchmarks are tricky, like you said. I think MMLU is pretty much, like solved in a sense, like saturated. And I think the problem is really, I think, with these benchmarks, they're only good for a few weeks or months until they get used. And it's this big problem that no one knows really how to fairly compare them. I mean, people use benchmarks that are like MMLU, multiple choice based for just sanity checking to see if the model contains knowledge. But then, knowledge is not everything that you need in an LLM nowadays. An LLM has to do many things, and so people, I think, more they trust more like these leaderboards, like Alpaca, the eval bench and stuff, like where you have users using them and then you get like a pairwise comparison between LLMs, like this is more useful than the other. But even that can be gamed. So the way this is currently being gamed is by style training, so that it's either implicit or explicit. Through the reinforcement learning reinforcement learning with human preferences, you train the LLM in a way that it's going to be the preferred answer when you compare two LLMs to each other. And it's hard for a person, if you're using two LLMs, to sometimes say whether one answer is better than the other. If you ask it like a knowledge question, I think most people would prefer the answer that is a bit more, I don't know, sophisticated or better explained. But it doesn't mean it's correct. So, it's like you as the user, you would have to do, let's say, an internet search and then find out, is this actually correct information? And it's tricky, I think. So there's no really good solution. Based on what I know, many or most companies developing LLMs, they have internal benchmarks that are a bit more, I would say, not unbiased, but for that, they at least know likely it's not leaked into the internet yet if it's something they privately created, and then it becomes a bit easier to evaluate. But it's still tricky. I think the most honest benchmarks are really like math and coding questions, where it's kind of like how DeepSeek was trained, where they had these verifiable rewards where you generate an answer and then you just use a lead code compiler, or let's say Wolfram Alpha, to just double check the answer. And then you have a style LLM that checks, or the style of the response is okay. I think it's like a training metric, but it's also kind of like an honest metric where, that double checks things, where it's not just like perception, it's really verifying the response. Whereas with the other ones, it's a bit trickier, I think, especially because the information leaks into the internet, basically. I think it's a good question. It's not solved yet, and I don't know how to really this can be solved at scale. Yeah.
There's a related question in the chat, I think.
But maybe one more thing I wanted to add
go
is,
ahead. Yeah, sorry.
So one problem is also when we have the like custom benchmarks, internal benchmarks, is it will be hard to compare them to other LLMs, because I think the appeal of the public benchmarks is that it's like something everyone uses, and so you can compare. But then once you introduce a new benchmark for your model, you don't know how the previous models did, unless you can maybe run these experiments, but then yeah, it's harder for people to have a reference. Like, oh, maybe it's just a benchmark they developed, so they look good on that benchmark. It's that is, I think, the problem. It's like how to balance between making something that is like the standard, but then also making sure the standard doesn't leak into the training data, basically. Sorry, there was like one trade-off I wanted to add.
There was a question regarding reasoning models. Do you think that, okay, LLM as judges is quite popular now for evaluating LLM applications, but is this paradigm going to change given that what additional consideration should we make when evaluating reasoning tasks comparing to evaluating old LLMs? I think you see the question as well, right, in the chat.
Oh, yeah, let me just double check. I think I have it right here. I think LLMs as a judge are, yeah, they are like a way of automating things. I mean, back in the day, or not back in the day, just a few years ago, with Instruct GPT, it was just all based on human evaluations, and that is expensive. And I think the LLM as a judge, it was just like to make that cheaper and to make that more automated. But then, yeah, it's also tricky. I mean, there are specific judge models, like I think one is called, based on Phi, it's called Fudge and so forth. I mean, they work, but yeah, it really depends. When you compare those, yeah, it's tricky. I think if the judge is not good, the evaluations won't be good, and getting a better judge, it's like it's a yeah, it's tricky. It's like all approximation. And I don't think it's gonna change that much though, because it's like one of the ways, yeah, to do that at scale. The other one, I mean, is really to use these verifiable rewards, like I mentioned, but you can only then prove that or show correctness in terms of, oh, this is the correct math response, this is the correct code generated, or things like that. But I think you still need like this LLM as a judge to judge the style. So like that the response format is correct, that it's not just, coming up with a shortcut, because that's one danger of reinforcement learning, is that it will try to exploit it by finding shortcuts to generate something that gets a high score, or maybe gets the correct answer, but then it doesn't have like the reasoning trace you care about. It learns to cheat basically. And so with the judge models, you can at least have some more constraints that are not easily encoded, like with like specific rules, as like where you can't really formulate, or what am I looking for? So you can show a judge like an example, like, hey, this is the style I'm looking for, and this is the LLM generated thing. Is this, roughly in the same ballpark, something like that. So yeah, I think for that, it's still going to be useful. But it's also always with a grain of salt. It's not perfect. It's like a trade-off. It's like the best we have at the moment, I would say. Yeah.
David, follow-up questions?
Yeah, just one question on the reasoning models that you mentioned, and you mentioned also that, for example, the reinforcement learning approach that was used basically to create this like very long chain of thoughts. I mean, this approach, for example, relies on the fact that you can train it on questions, right? They're kind of have an exact answer, right? They're like yes or no. Do you think there could be, a way to create kind of reasoning models that can reason about things that don't have like an exact question, and like ways to train them about that, right?
Yeah, so more like philosophical questions almost, where
yeah, I just think there's a lot of questions that they don't have like an exact answer, right? But you still can kind of like, let's say, logically reason around them, and you need like a concept of the world and a world model. And we know that this is a problem for many kind of LLM based models, right? Because they hallucinate, for example, and they just repeat knowledge they've picked up in the world. And so I think my question is, do you see like any other types of architectures that could help address this problem?
It's a good question. I think the hallucination,
neurosymbolic AI, for example, or things like this.
Yeah, it's a good question. I think so with the hallucination, the problem is always like when to hallucinate and when not. I mean, like
it's also a feature,
yeah. It's sometimes it's a feature, sometimes it's a bug, right? So it's it depends, because when you have historic facts, you don't want the model to hallucinate. You want to have memorization from ideally reputable sources like textbooks or something like that. But then sometimes, I mean, if it's just copying things from a textbook, why do you need an LM? You could have a search engine, right? So it's tricky to find or to balance when to hallucinate and when not. I think LLMs are getting much better in that sense, but it's never going to be perfect. And with world models or in general, like I think this might be I don't know, tricky to implement. I think I can see it more like on the agent level, where you have an LLM that generates a response, and then you have something else that double checks the response, where it's not baked into the architecture. It's more like a system of different things. But I'm just speculating. But I can see that, like one LLM generates the answer based on the internet. You have another LLM that has a fixed corpus of, I don't know, Wikipedia article or textbooks, and then there's like some judge that says, okay, these don't agree, but this is more trustworthy than this one. It's kind of already implicit in the training data, but making this more explicit, I can see that maybe. But I wouldn't know how to bake everything into the architecture itself with this architecture, the transformer architecture. I think it would be more like,
building something around it, like to kind of prevent which test time compute to some extent is, right, depending on how you implement
it. Is like that, It's where you generate multiple responses, and then you have these PRM models that compare them and select them. It's kind of like that, but maybe even it could be more symbolic or explicit, even like you said.
Okay.
Yeah, because do you see any is the transformer architecture the ultimate step, or we will have new architecture?
Yeah, that's a good question. I think right now it's just working, but also like with my book and everything, where I just describe how GPT models are built, and I get a lot of questions from readers always, like, why do we have like the Q, K, and V mate matrices? Like, why is that a good idea? And empirically it works. So there were like some papers. One is called, I think, Simplifying the Transformer Architecture. They got rid of some of the components, and they found it still works. But on the other hand, the original architecture also works, and people are just, never change a winning team type style where they just keep using it. But there are refinements, right? So there's, sliding window attention, group query attention to make it more efficient, or the multi-head latent attention in the DeepSeek models. So that tweaks, but, it's almost like, with cars, when you think of gasoline cars, like traditional cars, when they were invented, like, they have been around for like maybe 100 years, approximately, let's say 100 years or a bit more, and they are getting better to some point, right? So like Ferrari today is probably faster than a Ferrari 30 years ago. But I think maybe in 20 years or 10 years, that Ferrari won't be that much faster than a Ferrari today. So it's kind of like saturated almost, like where people were squeezing out the performance, making it more efficient to some extent. And then maybe people added these hybrid batteries to it. So, it's like kind of tweaking it, but it's fundamentally keeping the same thing, and you can only go so far. And then at some point it needs something different to be faster. I think electric cars are most of the time faster, but I'm not an expert in cars. I'm just saying is that analogy here that at some point there needs to be maybe something new. I don't know, where we are just squeezing still this architecture to get somewhat better performance, but at some point, there's only so much you can do maybe. And then it will be time to switch. It will take time, but
But any new architecture maybe that is emerging or not yet?
Yeah, I think right now the one thing that had promise always was so there are two things. One is like the state space models, but I think yeah, I don't know. I mean, it's I like that people are working on this. It's cool to see people having new ideas, trying out new things,
Mm,
but we haven't seen a big model yet, right? So I think the biggest model was maybe 7 billion. So and I think it compared favorably to transformer-based models. I might be wrong here, but I think I've seen 7 billion. But and they compared okay, or they were on the same ballpark. But I
mm,
don't know if that still holds when you train a 405 billion model or something like that, like on that scale, because it's the same. I mean, maybe it's not, but with DeepSeek, for example, when they tried the reinforcement learning with verifiable rewards, they found this one works only if you have a reasonably large base LLM. Like, so this is just an example. Some techniques they only work well if you have a large LLM, and
mm,
vice versa. Maybe some models they work only on small models because on a large model you don't get these advantages. You saturate earlier, and maybe that's like that with state space model. Maybe not. So I think what I'm trying to say is we don't know. Someone has to try it. But I think no one wants to try it because it's so expensive. Where if you are a company and like maybe OpenAI can afford it, but others maybe can't. It depends. Like the smaller companies that have cool ideas, it costs millions of dollars to train this model, and if it doesn't work, yeah, you basically wasted $1 million or something like that. And in that sense, it's hard to know whether they will be competitive at scale. So it remains to be seen. I mean, I think there are other architectures emerging, but one trend, yeah, is state space models now with attention mechanisms, as far as I know, like hybrid architectures. But I don't know if we ever see a big model in 100 billion parameter scales. Hopefully at some point, so we have some more insights. Yeah.
One more question just related to use cases, right? We don't see Gen AI yet penetrating, for example, regulated industries or like banking or do you have any experience implementing Gen AI in these kind
Um,
of very highly regulated industries?
I can't say too much there. One is because I
Mm,
do some consulting. I can't say too much, but like on a big scale, I think in general the risk is there's a risk always, right, with LLMs that they're not deterministic, and I think there's a lot. I mean, a lot of people or companies can't even just use the latest open source models because they need to go and
mm,
like they have like a mechanism to review each line of code like in regulated industries, and
mm,
that takes years sometimes just
yeah,
to make sure. And
mm,
I think with LLMs, I think the code is not so complicated,
mm,
but the non-deterministic nature is. So I think people are hesitant there, but I don't know for sure, but I can see them being used in a different way, more like as a tool to make the people working on the core applications more productive. I can also see, I don't
mm,
know, just saying anything that I have no real knowledge about, but I can see LLMs being used, for example, to develop the website or something like that, or like do you can do testing, like security
mm,
testing with LLMs, where you
mm,
don't have the LLM front and center to actually interact or do something,
mm.
but you have it as a tool for
As a
the developer.
support
Yeah,
tool,
yeah,
yeah, something like that.
yeah.
Somebody's asking about, okay, I'm jumping a bit left or right because we don't have so much time. And what do you think about LFM, liquid AI, and all that?
Actually, I don't know about liquid AI. That is maybe something I missed.
Okay,
Um,
okay.
I yeah, no, I wish I maybe have to write this down and look it up. Liquid AI. No, I
Yeah.
actually don't.
Okay, that's fine. What are your views on distilled smaller models? Do you think we can rely on them for now
Um,
scoped tasks?
I think I don't want to be offensive here, but I think it's more like a party trick, like these distilled models that they work so well. It's like they give you the
Yeah.
illusion that they work well. I mean, they do work well, actually. That's a cool thing about them. They do work well, but only as long as you stay within a certain framework or like distribution. Like I think yeah, they're basically mimicking what the bigger model is doing. So they appear smart and they are useful actually, but
Mm,
I think they're also still, I mean, at the same time limited, but it's interesting. I think these distilled models, they will be very interesting and useful for these private applications where you have a very specific use case and you can test them on that.
Like regulated industries,
yeah, maybe. Yeah. Because I think but you have to narrow down the input. So I think that's true for all the LLMs. As soon as you go off distributions, out of distribution, they will do something weird. But I think with distilled models, they fail even more. Because they are just more limited. They can't, they have less, I don't know, flexibility to improvise, I guess. But what is impressive is how far you can go with these. Like with I think there was in the R1 paper, they had I think a 7 billion model that was almost as good as O1 or something like that. So it is impressive actually. But then the thing is, they always depend on a larger model, right? So as soon as you stop developing the larger LLMs, you will also stop making progress with distilled models. So it's always it's almost like an economic thing where you develop this big LLM in order to develop this smaller distilled LLM for real world use cases. I don't know for sure, but I can imagine O3 mini is also a distilled model where they have this big O3 model and then they did that O3 mini because that's cheaper to deploy and to use for now. Something like I think they're super useful, but like O3 mini is, I mean, it's useful, but not for everything. It's
Okay. Last question, maybe. David, you have one more question?
No, I think there are some in the chat.
Some in the chat. What are your thoughts on synthetic data generation and model collapse?
I do think so back in December, I read a paper, the 5.4 paper. They did actually use a lot of synthetic data, like more than, I think, 40%, 50%. And I think so that's also the thing with distillation we just talked about. Distillation nowadays means essentially training on synthetic data, where the synthetic data is specifically generated by the larger model. But traditionally, distillation was something different. It was also training on the logits of the larger model. Now it's basically even more simpler, training the model on data generated by a larger model. And as we just talked about, distilled models are actually quite good. So synthetic data is quite useful, but it has the limitations. You have to have the larger model generating the data. But so far, based on what I've seen, I mean, most papers or most models like Gemma, Phi, the Apple Foundation models, I think Llama 2 to some extent, they all use some synthetic data now. And I think it's to train the model more efficiently. So when you start with raw data, like internet data, it's usually messier. And it takes the model more time to learn the structure because the style changes, especially if you shuffle the data. You have Reddit, you have textbooks. I mean, people work on making the ideal mix and also the ideal sequence, but still it's kind of messier. And when you have synthetic data that has been generated by an LM, it's usually in a well-structured format, and it's usually grammatically correct already. So you give the data, so the model, more high-quality data in a sense. It might have wrong information, but I think it helps the model to learn faster how to write well. It's like information diet almost, where you give it the preferred style, and then you have to spend less money and time later on for the fine tuning. I think it's just like accelerating the training in a sense, but you can't only rely on that.
Cool. Sebastian, was great. Great speaking to you.
Thanks for inviting me, and sorry again about that mishap with the link.
No worries. But thanks again. I'll put the recording on LinkedIn a bit later on YouTube. So thanks again, Sebastian. It was great speaking to you.
Thank you, and have a great weekend.
Have a great weekend as well. Thanks. Bye-bye, everybody.
Thanks.
Thank you.
Thank you.